Welcome to the bench, friends. This is Joe, Blue Oval Racing, HO Scale Custom and Performance. Today, we're going to be working on scrap build, and I'm going to show you something I made for testing armatures. Consists of a couple of alligator clips, 2 pieces of solid stranded copper wire, 1 strand, each piece, solid strand. I think this is like number 18 wire. The coating is only removed on the tip. So copper, nowhere the actual bare wire is touching this metal alligator clip, so it won't get a reading if I touch it. When I'm doing an ohm, testing the armature on setting the multimeter set on ohms. The wire runs through the alligator clip on each side of the spring, and shrink tubing on the end to hold it in place. Now, you can make yours different if you make one like this. I'm going to be taking this one. This was for testing purposes. I'm going to be removing these 2 bottom alligator clips, and on this relatively inexpensive multimeter I have, which is fairly accurate, I compared it to other meters that I do have, and this one's not bad. I will cut these probes off, skin the wire, cut the alligator clips off, skin the wire, and solder them together and put a piece of shrink tubing on it. Is what my plan is now that I know this worked. You can actually buy something like this from Wizard Performance, but you can make one cheap. So let's get on with it. Let's zoom out a little bit. So, how this works, let's test an armature. Things are jumping all over the place. Alligator clip. Doesn't matter which side goes on what. We're going to be reading ohms. So it doesn't matter black or red with the alligator clips. You just don't want them to touch, or you will get a reading when you have your multimeter set to ohms. You want to keep them separated during the test. That's why soldering these together and put a shrink tubing on it will be a great help. But like I said, I wanted to construct this one for testing purposes to see if how it's going to work. We have our multimeter set on the lowest setting under ohms, which is 200 on this meter. This is a Viper 2.4 high-speed armature. It's brand new. It's not balanced. And you set the armature. Now the commutator has 3 sections, and you'll see a gap between the sections. So you have 3 gaps, spaces, between 3 pieces on the commutator, 3 individuals. That's how the armature's wrapped with the wire and soldered, but we're not going to get into that. You can research that on Google all you want, but I'm not going to get into that part. You put your armature in like that, and you spin the armature, and you'll get your readings on a meter. Now, when you hit one of those gaps, when you're crossing over from on the commutator to each section of the commutator, when you're reading on a meter, you'll see a fluctuation, especially when you hit the gap where you might be reading 2 at once with one side of the probe. Not to get you confused, which I probably am, but let's take a look at the meter. So, when I say this was a 2.4 2.4 ohms. Let's zoom in. All right, so what I'll do is I will spin the armature. All right, we got 2.4. We're spinning it slowly. See that little erratic right there? Watch, I'll back it up. That's because we're spinning through one of those spaces back to where, there's another one. So anyway, let's get on with it. 2.4, 2.4, 2.4, 2.4. And see, here's where I'm hitting that space going to the next section. Let's see, I'll do it again. Hold up. Right there. See how it fluctuates? That's just because I'm crossing over where the gap is between two sections at once. So there we go. 2.4, 2.4, 2.4. This armature's good. Oh, I think I didn't get this on camera. Let me zoom out. Let's do it again. We'll spin it. 2.4. There's right there. I'm backing it up forward and backward. That's where we're hitting that space between two sections, that gap. 2.4. 2.4. And last but not least, 2.4. So I hope this makes sense. I'm sure most of you out there know how to check an armature to see if it's bad or not. It's just, this makes it easier than trying to hold this in something and using two probes. So this armature is good. Now, let's take scrap build, which has been acting up lately. I believe I know what's wrong with scrap build. This is a Viper chassis, and the parts I used, the motor magnets, the armature, the traction magnets, and the end bell and the other electrical components I already had. These were from other builds that I took apart. Either the chassis cracked, broke, the motor burned up, and I just took them apart and threw them in a bin like this with my parts. So anyway, I built this car, and it was running pretty good for a while. Well, I believe I installed a little bit too small of diameter rear tires and front tires. I had the car running too low. It was dragging. I'm running it on an AFX track. And this car was more suited for a routed track, the way it's set up. So, you probably can see, there's nothing wrong with your traction magnets rubbing, as long as you're not rubbing too much and you're still getting enough air under the car to keep the armature cool. But in my case, I have a funny feeling that I self-inflicted the pain upon this beautiful HO slot car chassis. I did it myself. But let's tear it apart and check the armature out, shall we? Traction magnets are level 10. Motor magnets are level 14. Level 4. 14. Level 4. And this desk is a little noisy. Check the end bell. The brushes are good. The tension on the arms that the brushes are connected to are good. It's evenly spaced, so no issues with the end bell. So let's go ahead and I already did clean this with contact cleaner. Let's go ahead and run a piece of fine emery cloth on the commutator prior to testing. Let's take the meter. Now this is a 6 ohm armature. Let's put the armature in. All right, we're going to go ahead and start spinning. See what we got. Well, this is already not looking good. All right, so here we have 6.2. All right, 6.1, 6.1, 6.2, so 6.1. Let's spin it to the next section. And there we are. We're at 17, say 17.8. I hope you can see that. That's not good. If you have 16, if it's a 6 ohm armature and you have 6, 5.8, 5.9, 5.6, but they're all within reason. You go section to section to section 3 times, and the reading comes out, say 6.1, 6.1, 6.0, you're okay. 6.1, 6.1, 6.2, you're okay. Even a 5.9 to a 6.01 is fine. But this is not good. This is a 6 ohm armature. And we have one reading where it is 17.6. Let's spin it. All right, here's another one. 17, 15 something. Spin it again. There we're back to 6. Yeah, this is just bad. Those numbers are all over the place. Look at that. We fried this motor. It's supposed to be 6 ohm. We've got 6.1. Spin it. We've got 18 something. Now we're 19 something. This is all over the place. Yeah. You get the picture. There's a 17.7 now. So this armature's toasted. It did toast. It did burn up because I actually smelled the car. Burn. The armature burn up. So that's a bad armature. If you have a fluctuation that much, let's go back to where we got 6.1. I mean, we're at 20 some on that one. Go back to the 6.1. Where's it at? There it is. 6.1. And then all the rest of them, the other 2 are all over the place. There we are. We're back to 17 something. Spin to the next one. We're at 32 point something. this armature's shot. Hope this makes sense. For those of you who already know how to test your armature, you may already have something like this, or you might say, hey, I need to make one of them. It looks like a pretty handy tool. So this is where we're at. We have a burned up armature in scrap build. So what we are going to do, I'm going to put the meter away first. We're going to take scrap build. We're going to take the 2.4 hot high-speed armature from Viper, and we're going to drop it in this car with the Pro 4 motor magnets and the Pro 10 traction magnets. We could go up to the Pro 10s. I have a set, but we're going to test it with the Pro 4. Should work, should be fine. I usually put a 5 spacer on the armature. Let's go ahead and get the ball rolling on this. My clock is going tickety-tock. First, rear bushing. Six-tooth, no, this is 7-tooth pinion gear. I don't know where I got 6-tooth at, but goes my stomach, and I just ate lunch. Okie dokie. Just want to push that hanger up for the shoe just a little bit, and then clickety click right in, piece of cake. I should have oiled that armature to the back end before I put that bushing on. I didn't do it. See how that end play is. That's not good. It's a little tight. Sounds good. Now this is a stiff chassis. Actually, this particular chassis, I purchased from Viper. Oh boy. This was close to the time they first released these chassis. I bought this as a bare chassis. Actually from Hardin Creek, from Terry. Ooh, it's been a while. This is the first Viper chassis I purchased. Now you're wondering, how do I know that? Because I only have 2 Viper chassis that the body posts are gone. One of them I cut off, which mine are flush, and I have this one where these are indented slightly. That's how I know which chassis is what. All the rest of them have the body post on them. I only have 2 of them without. All right. And that's it, folks. We will run this during the next video. I am going to find some slightly larger in diameter tires for the front and the rear. And that's it for this video. So we now have a 2.4, what is it, a high-speed, high-speed armature. Sitting pretty into this Viper chassis. And in the next video, we're going to take this old girl for a run, who we have now breathed new life into with a lower ohm, high-performance motor, armature. Until next time.